Well, good morning, everyone. Thanks for coming. My name is Jimmy Bogard. You can find me on Twitter at @jbogard. All the code you see today, as well as the slides, you can find on my GitHub at github.com/jbogard. Excuse me. And I blog about this topic and a lot of other things on my blog at jimmybogard.com. This is actually a topic I wish I didn't have to talk about. I wish I didn't have to worry about security and things are just like easy to connect upon the web and people didn't try to hack it and things like that. But that's not the case. I do have to worry about security, and so this talk is about a project I recently worked on in which I had to take basically a crash course in all things security and understanding how to deploy secure microservices into Azure. So things used to be quite a bit simpler. We used to just have like a very basic client-server application, so we would build server-side web applications. Remember those things where like the HTML was built on the server as opposed to the client? Excuse me. And then there was a talk to a database, and we would secure the communication from the server to the database, so nothing could talk straight to the database directly, of course. We would have that behind a firewall or something. And then we just had a client, and things were simple. In order to secure these things, we would use a cookie to be able to secure this. So we'd have a like ASP.NET Core or ASP.NET Secure cookie that was encrypted, and only the server could read it. It was stored securely on the client as well, and no one else could communicate to our server unless they had that cookie and they were authenticated. So that was pretty simple, right? Like that's the days I wish I could go back to. But unfortunately, things are not simple anymore. We added microservices to the mix, which means a lot more servers, a lot more things talking to each other. And so the story becomes quite a bit more complex when we're talking about adding a lot of other different distributed components to the mix. So this is my situation that I was presented with, which was I had a client that was, of course, a SPA, because you have to these days, right? So it was an Angular SPA. That was talking to a single API that was the backend for frontend. And so that backend for frontend represented how to pull all the different services behind the scenes, formulate responses for whatever the SPA needed, and then the SPA would just talk to that one single API. And then behind the scenes, the BFF would then talk to all the different backend microservices that had their own databases, their own applications, they're all running on like Kubernetes or some junk, and be able to pull that data back together for that response I was then showing on the screen. We also had a lot of on-prem servers as well. So we had like still existing legacy applications, legacy systems that were on-premise, also talking to these APIs, and also needed to pull back data to be able to be shown on their different screens. So this is the question we were posed is, okay, the previous picture, where we just had like a single client server, we understood that picture very well, like how to secure that, like you log in, you get a cookie, everything's good. But how do you secure this picture? And by the way, I'm not talking about network security. I have no idea about any of that stuff. So if you're looking about network security, like this is not the talk for you because I'm not the person to be talking to about that. We were mainly looking at the like APIs themselves. How do you secure these different APIs together so that the data that was being shown in each of these different systems was the data shown to the right person. It was also health data and personal information, so we wanted to make sure that the wrong person couldn't see the wrong person's data. And so that was our big question, was how do we authenticate and authorize these different external users to our system? Now, for the external users, the people that were like the actual users of the system, they never talked directly to any of our individual microservices. In fact, no external user whatsoever, internal users or external users talk directly to these services. They're always going through something else, some other API or some other system that then talk to our backend microservices. So the front end, we saw that, okay, the front end users who have a regular kind of login, that was actually somewhat straightforward because we were using Auth0 at the time to authenticate those initial users. So they would go to some kind of single sign-in page, they'd enter their credentials, and then when they would get logged in and get a secure cookie to the backend for front end, as well as the token. However, all the other background systems and services didn't understand Auth0, and complicating the matters was all these things on the right over there, all those on-prem systems also don't use Auth0. They were just still using like forms, authentication, login, cookies, things like that. So we couldn't just say, let's just take that token that we got from Auth0 and flow it through all the services because those things on the right don't have any concept of Auth0 and didn't have any sort of token. So we're living in this world that was very mixed authentication environment where we had like modern sort of logins over here, and then like old kind of crusty logins over here on the right. And the things in the middle had to be able to speak both languages. So our unanswered questions was, we could understand how to secure the things that were on the outside of that diagram. We understood how to secure the BFF, that could just use cookies. We understood how we could secure the existing applications. They could just keep doing what they're already doing. But all those things in the middle, all those microservices that had that critical business data, the critical user information, how could we secure those different pieces from both directions in a way that was consistent and still maintainable? So years ago, someone else I knew, not myself, definitely not, would just say, well, you know what? We're already inside the network, right? We're already past the firewall. Why do we need security at all? Why do we even need like HTTPS, transport security? Just build these internal APIs and assume that if they were able to get into the first server, then they should be okay with everything beyond that. So just don't do any security at all. It wasn't me, someone else. I don't know, I'm sure. And so we also had to worry about all the on-prem people as well, that we had to worry about, okay, the internal Azure communication as well as the on-prem communication. So people smarter than myself looked at this picture and said, right, this could be a security disaster if we just do nothing here. If we just let anyone communicate to these APIs that has this protected health information, that has personal identifiable information. We can't just allow anyone, if they just happen to be on the network, to be able to call these APIs and get whatever information they want. So instead, we were trying to shoot for what I learned later was called the zero trust model. And the idea here is that we never trust any bit of communication, and we always verify. So we always verify any sort of communication between one system and the other, and never just say like, well, if you made it this far, I'm sure you're good. So our first thought was, well, why don't we just flow that user token? So take that same auth0, actually at the time we were using identity server, transitioning to auth0, and say, let's just take that JOT and just flow it through all the communications downstream. Say, we'll just keep passing that connection along. That would work great, except two problems. One, none of the things on the right had any concept of a user token to begin with. They had a cookie. And the other thing we were running into was that not every single kind of call in our system was made by a user. Sometimes we had things like batch jobs or messaging that would not have a user whatsoever, or they were making calls to our API, so we don't have any concept or context to say who that specific user was that kicked this thing off. They didn't exist. So this looked great in concept, but broke down pretty quickly when we looked at the different kind of scenarios. So our solution was, right, we can't use the identity provider on the right as just a thing we're going to use everywhere. And the things over here have no concept of this thing on the right, the auth0 components. Then we need to find some homogeneous solution for all these different connections in the middle. And because we were hosted on Azure, we said, right, why don't we use Azure AD to secure all the communications inside of this picture? So every single arrow here, once I got inside of Azure as well as the on-prem network, all of those would use Azure AD, Azure Active Directory. I think it's called Microsoft Identity. They've rebranded yet again. In any case, we would use that as the thing that would be able to secure a token and secure like who you are and what you're looking for inside of all these different communications. So this is basically the picture that we were given to by the security folks. Like, yes, do this. I said, great. How do we do that? They said, that's not our problem. I said, uh-oh. Now I have to figure this out. So we had to figure out, okay, for each of these different arrows here, how should those different systems authenticate with Azure Active Directory? So Azure Active Directory supports a number of different, basically all of the different OAuth 2.0 flows. And again, this is one of the things I wish I didn't have to worry about. I wish we could just use cookies and everything's wonderful. But no, this is more complicated with microservices, all these different systems. So we had to figure out, okay, how should each of these systems, when I want to call from system A to system B, how should those systems authenticate and acquire that token? And there are a lot of different options available to us in OAuth 2.0. This is from the Microsoft documentation about here's all the different kinds of apps that you could build, and these are the different ways you can or you should acquire token for each of these different situations. So if you have a spa, you should use auth code with PKCE for whatever PKCE means. And then the kinds of things you can authenticate against, like who can actually authenticate, are the fun things of Azure AD, which are work or school accounts, personal accounts, or Azure B2C, which no one should ever use. And so looking at all these, like, okay, we started going down the list. Okay, that doesn't look like us. That doesn't look like us. That doesn't look like us. That doesn't look like. Wait a second. We have a web API that calls other web APIs. That's our backend for front end. It's an API that calls other APIs. We also have daemon apps, or these background services that also call APIs. And so they told us that you can, now you're down to these two options for OAuth 2.0. One is the on behalf of flow, which is basically, I get a token, and then my service needs to call another thing, so it acquires a token on behalf of that token. So I don't flow the same token down. Instead, I acquire a new token on behalf of that calling user, and that new token will then also include the information or the claims from that initial user. That seems pretty good, except the kinds of accounts I can use here are only work or school accounts, whatever that means, or personal accounts. So that means that I can only use tokens that originate from Azure AD to use that flow. That's the limitation of Azure AD. So we saw that, like, that would have been nice. It would have been nice to say, okay, you're this specific user, so only show the data or hide the data based on that. So we said, okay, we can't do the on behalf of flow because you're not an Azure AD user to begin with. We have the on-prem systems that have no tokens, and the client systems that are just using Auth0 and identity servers, so that one's out. So they basically just reduced us down to this one, which is daemon apps that call web APIs. So everything that was going to call our different services would need to use client credentials, which is every single client gets a client ID and a client secrets, which you have to keep secure. And then using that client ID and client secrets, they call Azure AD to get a token. And after they get a token, they can then call our API, passing in that token through the authorization header, and then everything should work OK. Long journey to just like choose that one different option there. Now that's just how to authenticate, which is to establish the identity of the caller. The second part then is how to authorize those callers. So in Azure AD, once I go the route of client credentials, that is machine-to-machine communication, you have two options to authorize individual callers. The first option is known as access control lists, or ACLs, which is just a fancy name for just do whatever you want inside of your application. It's all custom logic. You just like take the token, look who's calling you, and say, right, are you authorized to be able to call this API endpoint, or are you not authorized to call this API endpoint? But it's all just custom logic inside of your application. There's nothing fancy or special. I'll look at who the client ID is that's calling me, and do I trust them or not? And if I don't trust them for this specific call, then I say, you can't call me. But that requires us to have each application maintain its own access control list. It has to have that list of who are the authorized callers for this API. Or I could just say, don't do that. Just say, as long as you have a valid token, you can call us, which, again, we were trying to avoid because we were trying to go the zero trust model. On the other option, though, is known as application permissions. And the idea here is that I define custom roles that are modeled as permissions inside of Azure AD, and then I can assign those different custom roles or permissions to individual server principals. And then when I acquire a token as client A calling to server B, I ask Azure AD, I want a token for that resource. And then Azure AD looks up, do you have any roles or permissions assigned for that resource? And then the token that you get back will contain all those roles or permissions for that one specific resource. And then the server, once it receives that token, will then say, for this API call, are you authorized for this individual role or permission? So I don't care who you are. I just care, do you have this specific role or permission? So we like that one because our individual applications then don't have to maintain that custom list of who is calling me and what do they have. Instead, I just say, do you have this permission? And that's it. And that assignment of the permission is then done outside of our application, outside of our system. So from this, we boiled it down and said, based on this complex scenario of microservices, on-prem, all that sort of stuff, we were able to build a very simplified application or simplified system that represented the kind of two main use cases in our application. We have internal Azure communication, so that's like something deployed to Azure, calling out something else deployed inside of Azure. And then we also have these external clients that are calling into our system as well. These external clients are not deployed to Azure. And our demo, it'll just be deployed to my old laptop here. But the idea is that it's not inside of the Azure ecosystem, so our choices become a little bit more limited into how we secure that individual communication. At no point, though, do we have any kind of external client talking or external user application talking directly to our APIs. So the browser does not talk directly to our application. It has to go through this other API that then calls our API. So I don't have to worry about all those different other user flows, and we can make sure that these backend servers then are not actually exposed to the public internet, all those sort of things. All right. Excuse me. So I've got these basic scenarios laid out. I have internal Azure communication. I have external Azure communication to our system. The next piece we need to decide is, OK, we want to use this role-based authorization. What are the roles? So we had to figure out what kind of makes sense for all of our APIs to define these individual roles for our different APIs. So in this application I'll be showing you, it's trying to have something a little more complex. So it's not just a straight read-only API. It's a to-do API that has all sorts of different API endpoints to be able to modify, add new to-do items, and delete them as well. So we've got our normal kind of CRUD-oriented API here. We have get, put, post, and delete. So looking at this, we needed to define individual roles for each of these different kind of API endpoints. So we had to go back and look at, well, what are the kind of use cases we're looking at to be able to kind of decide what sort of granularity we could put on these different roles. So I could be extremely granular, so every API endpoint has its own distinct individual application permission. So I have to-do.read, to-do.update, to-do.create, to-do.delete. But then we looked at our applications, we saw that, well, there's not really that sort of breakdown this application can create something, but that application can only update something. There was never that sort of breakdown. Instead, what we had was there are certain systems that could read the data, and there were certain systems that can read and write the data. So we wound up mapping those roles and permissions out to something a bit more simplified that was just read and write. Now again, you don't have to go this route of creating application permissions. You could just use the access control list and say, if you've got a token in my list of qualified people that can call me, then you're good to go. Well, we found this, though, because we were dealing with protected health information and protected user data governed by laws and regulations and such. We only wanted specific applications to call us that we knew that could then apply those appropriate data protection, privacy attributes to that data before it actually went out the door to the end user. So we wound up going the application permission route to ensure that only the specific applications that can read this protected data, because not all of it was protected, that were then those applications they could call us. But other applications that didn't have that sort of capabilities to be able to protect that data said, well, you can only get the access to the APIs that don't have that information inside of it. So we went up the application permission route and tried to just focus the granularity of these permissions based on the overall business use cases. There's not a lot of documentation or guidance from Microsoft or any other identity provider out there, really, about what these application permissions could or should be. So we kind of had to figure it out based on our individual use case. So with that, let's go to our demo. And our demo is going to be exactly this, in which we have a server deployed into Azure. We have an Azure client, which is another API deployed into Azure. And then we have an external client, which is just represented as a worker application calling our API from my laptop. And, all right. So I've got Visual Studio here. I've got, in our application here, in our solution, I've got my Azure server. So this is an API that will be then deployed out to Azure as an app service. I have an Azure client, which is another web API that calls our API, also deployed out into Azure. And then finally, I have the external client, and that piece is the application that will be just running on my laptop. So first things first, we need to build out the Azure AD resources in order to secure our server. So we'll go to the server first, then we'll look at the external client, and then we'll look at the Azure client. Now, to build these resources out, I could go to the Azure portal and kind of click around there to create all these different resources, but that's no fun. I also wanted to use infrastructure as code because that makes it a little bit easier for us to understand the actual resources being created for us behind the scenes. So I'm using Pulumi. This is not a Pulumi talk. I'm just using Pulumi because C#. And so we'll be using Pulumi to create all the different Azure resources for our servers and our clients. All right, so let's first go to our server resource. It's empty now, but we'll soon have stuff inside of it. So the first thing we need inside of this to create our server is going to be the actual app service. So I'll go ahead and create that first. So this app service is an Azure app service. And so it's just a web application that calls our Azure server application. So it's just .NET Azure server. And so this is going to be the actual deployed application inside of Azure. But it has no security associated with it by itself. If we want to add security to it, we have to add additional resources to it. So the next thing we're going to add is our server application. OK, so this server application is a secured resource inside of Azure. So when you want to secure any kind of API or, I guess mainly APIs, then you have to have some kind of container for all those different security roles. And that's going to be this application here. I will go over to the Azure portal just to show what this looks like. So I'm going to go to, it's called app registrations. And this is our Azure AD example server. So when I run this Pulumi up command, it will create this application here. Now, every single kind of identity provider, OAuth 2.0, like a token provider, has different concepts for how you secure these kind of standalone applications. So Auth0 has its model of how to secure applications. Okta has its model. Azure AD has its model. Identity Server has its model. But the general idea is that if I don't have a user that's calling different APIs, if I have another application calling other APIs, then it's going to need to use the client credentials flow to acquire a token, and they need some way to identify who the clients are and who the servers are. So an application or app registration inside of Azure represents that identity of some application that's calling another application. So it represents both the client and the server. All right, so this is our server application. Not a lot going on here. I just say here's my here's the name of the application. So that Azure AD example server is what I see right here. And then I have a specific URI to identify it. So instead of going based off like a GUID when I'm wanting to get a token for something, I will use this URI itself, and that shows up right here, API/example server. Yeah, there we go. OK. So that by itself is just a container for what is going to be our security rules. The next thing I need to define, though, is our roles or permissions for this API. So the roles are going to live inside of Azure AD, and then my application is then going to authorize those roles. But Azure does need to understand what are the different permissions and roles from my application so that when I acquire a token for a resource, it can say, do you have this permission? So I will now create our roles. There we are. All right, so I'm defining two application roles here. One is to-do.read, and one is to-do.write. And over here, these two components here are just IDs of these roles, because when I want to assign a role to another resource, I need to know which role I'm assigning, and so those IDs are the things I'll be using to say, assign this role with this ID to this client for this server. All right. So at this point, my server has its roles defined as part of it. If I go to the portal, if I go to app roles, I will see now to-do.write and to-do.read. By the way, I'm not actually running Pulumi up all the time because I don't trust the Azure to be able to do the things in real time while we're doing this demo. So I've already run all these different Pulumi commands. I'm just going to be adding them one by one and explaining as we go. A little bit of a cheat, but that's OK. All right, so I've defined these two different application roles, to-do.write and to-do.read. How do I assign app roles? Yes, let's look at that next. But first, we've created these roles. we need to have our server actually enforce this authentication and authorization, these authentication rules. So now I will go back to my server application and add the code necessary for it to authenticate via Azure AD and authorize against those specific app roles. OK, so this is just a normal kind of vanilla web API. I've got API controllers here that does the to-do items. This one does all the get, put, post, delete. And then I also have another API just to show like what it would look like to not secure an API. So I have an API that doesn't, this endpoint is just, I guess, weather, so it's not that interesting. So this one will not have security associated with it. The to-do one will. OK, so first, we'll pull this over. And we need to tell our server to authenticate using Azure AD. And to do so, we'll be using the Microsoft Identity Web package. So this package integrates directly with ASP.NET Core to give you all that middleware authentication authorization against Azure AD. Underneath the covers, it's not doing anything. I guess it is doing something interesting. It is going to look at the incoming requests, look at the authorization header, grab that bearer token, that JOT, look at the issuer and say, are you a valid JOT for this, for Azure AD? And are you calling my API that I am identified with this specific ID? And so to get all that, we just say add Microsoft Identity Web Authentication. Let me bump this font up just a little bit. Oh, that was a lot. All right. So we say add Microsoft Identity Web API Authentication, and then we'll pass in our configuration to say these are the different configuration values for who are you, what is your, what issuer should you validate against, that sort of thing. So to determine like what I should be authenticating against, yes, we'll go to this one. We need our configuration. So what is this configuration that we need? I'll just pull it over first. We need to understand what is our authentication server. So what is the instance of Azure AD that we're authenticating against? This is just like the normal Azure AD login, but if I had a custom URL or custom kind of landing point for Azure AD, that would be that different URL there. I need to know the Azure AD tenant. So this is the same for all of my Azure AD resources. So all the users, all the groups, everything is going to be umbrellaed into that single tenant. And then the next thing I need to know is, who are you? Like, who is this server? And so I have to give it the client ID. This is a little confusing because I have clients and I have servers, and they both are called applications, and they all both have client IDs. So this client ID represents the client ID of the server, even though it's called client ID. Where do I get this? I get it from here. I have a application client ID. I have the directory and tenant ID. And those two pieces I'll drop in right here. Actually, I can get it from Pulumi. So I'm using Pulumi to spit out the different configuration values. So my server application client ID is this, as well as the host name and other things we'll be creating here in a little bit. All right. So I've got all my configuration here. This configuration then feeds directly into this call here. And so the server will then look at the token and say, was it issued by this authority, this issuer? So loginmicrosoft.com. And is the audience this specific ID? And is the other thing, the server I'm wanting to talk to, is that also in that token as well? So it looks at all that configured and matches it all up and says, right, do all these different values exist in that token? Then you're good to go. All right. Now, in my API, I have to authorize those individual roles. So I will say over here, this is the get action, so that will be to-do.read. This is another get action, so that will also be to-do.read. This is a put action, so that will be to-do.write. And then this action will also be a post, so that's going to be to-do.write. And then delete to-do.write as well. So this is kind of funny. I have authorized, and I'm authorizing specific roles with this role that is our, excuse me, that is our permission. So we have a permission called to-do.write and to-do.read, and behind the scenes, this authorize attribute will look at our identity, the principal, and say, do you have this role? But where do those roles come from? How did ASP.NET Core know how to take that token and then populate those roles and my identity and my principal inside of this? So right here, this is just a normal authorized attribute. I'm not telling it to use Azure AD or anything like that. So something is translating from the roles coming in on the token to the roles being assigned to my individual identity and principal. So that's the last piece of this configuration here. I tell it that the role claim type is called roles. So on my token, we will have a claim called roles that is the list of all the different permissions that have been assigned to this resource. And then Azure, the Microsoft Identity Web middleware will take that incoming claim, take those roles, and then apply those roles to our identity underneath the covers. So then in our controller, all we got to do is then authorize this specific role. Now, if I were to run this application, actually, let's just run it. When I want to test this locally, I'm going to have a problem. Because if I try to call any of these APIs, let's try it out. When I execute this API locally, oh, unauthorized, because we're not supplying a token to this server. And so locally, it's like, well, I still need a token for you to call me, and you don't have one. So our next problem was, how do we achieve local development with this API that's only supposed to be called by other APIs? I still need to be able to get a token as me, a developer, calling this API locally. I could turn off security locally, but that's no fun, right? We still want to test out these different flows and these different middleware, so I still want to be able to call this API and get a token. So how do I, as a user, acquire a token for this API? Well, we had to go back to that list of different OAuth 2 protocols and say, what makes sense as a user calling this web application to call this API? Naive me said, let's just use the same protocols we were trying to use for everything else. Let's use client credentials. So I have a client ID and a client secret, and I will supply that client ID and secret inside that Swagger UI, and then I'll acquire a token to get that information, to get that token. Not so fast, Azure says. I will not issue you a token if you originate from a browser using client credentials. Why not? Because you should never use client credentials inside a browser or desktop or client application, because we don't have the ability to store that client secret securely. So Azure AD says, no, thank you. You can't do that. And so if we tried to use client ID and client secret, the client credentials flow, via Swagger, Azure AD would reject that and say, I don't support that flow from this specific resource, which is a browser. OK, so what can we do instead? Well, we'll just use one of those other application flows. And so when we looked at a browser server calling an application, it told us to use the authorization code flow. And so I do have a user in Azure AD, like me, my actual account. So what if my user gets access to the API, and then me as the user developing locally, I acquire a token on behalf of myself using the auth code flow, and then I get that token from Azure AD that represents me calling the API versus some other server. But to do so, we need to authorize my user to have those specific application permissions. I can acquire a token via Azure AD, but if I want to acquire a token for that specific resource, for this server, then I need to be assigned those permissions so that I get those roles in my JOT. So let's do that. To do so, I'm going to need some more Azure AD resources. Let's go back over here to Azure AD. And then over in our server, actually, this is going to be in, yep, that's right. In order to acquire a token as me, the individual user, I need to apply a couple other things on top of Azure AD. So the first thing I need to do is define a scope for which my user will ask for permissions. This is just a made-up scope. So it's just a limitation of Azure AD, unfortunately, that says if you're an end user asking for a token via auth code flow, then you need to authorize against a scope. And so I don't care what scope it is, just make something up. And so he said, right, this scope will just called local dev. And then when I ask for the local dev scope, I'll also get my other claims, which are going to be the roles. The next thing I need to do is modify my application definition in Azure to accept this new kind of authorization code flow. Let me go ahead and add that next. So I say I'm going to expose an API that has this OAuth 2 permission scope called local dev. So there's the local dev scope with this ID. And then I will also include a redirect URI that I say this is OK for us to do this specific flow. So this redirect URI is going to be my Swagger redirect. So when I try to acquire a token from my local browser running on my desktop, then it will say, oh, yes, this is an OK redirect to be able to get your token. All right. Now, the next thing we're going to need is going to be our assignments of those roles to my user. So I'm going to go ahead and pull that over here. So we have a few resources here. One is going to be the principal that's going to be the target of assignment of our roles. So that's this server service principal. The application itself, I can't secure directly. So the way Azure AD works is everything is done via principals. And then this application will then now have a principal attached to it. So the roles I'm assigning are not to the application, but instead to this other securable resource. There's like a database diagram calling out somewhere that's like, there's a principal table, and I've got like application table that links to that principal table, and I got users that are also principals, and groups that are also principals. And those are the things I assign roles to, not these like applications themselves. The next thing I need to do is say that it's OK for Visual Studio that's running locally to be able to make authorization requests. So this one is saying, I will say it's OK for Visual Studio to ask for a token from API. And this is a quote, 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 well-known client ID that you have to Google for. And it's one of the things that you Google for it, and there's like a bazillion results on Stack Overflow of like, what is this ridiculous GUID that I have to stick in here to be able to call my API? Well, this is it. When Visual Studio makes a call out to get our API, the application ID it uses is this one. And it hasn't changed in like 12 years, so it's OK to hard code it. If they change that, so many things would break, so that's just what it is. There are other sources I can use to be able to call that. So if I'm using the Azure CLI or Visual Studio Code, those also have their own client ID. So you just Google, Visual Studio Code client ID, and you'll find that other, quote, 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 well-known GUID. All right. Lastly, I need to assign my user those individual roles. And so I'll do that right here. I will have two methods here. One is to assign the read, and one is to assign the write. And so to assign the read permission, I have to say, who is the principal that I'm assigning to, what is the role I'm assigning, and what is the then client ID of the principal that I'm assigning that role for. So I need to know like the client, the server, and the role. And so that's all here. I have an app role assignment that includes the app role ID, the ID of the role I'm assigning. I have the principal in which I'm assigning for, and then I finally have the resource in which is going to receive the principal I'm assigning for, the client, and the resource of the server, which is the server service principal object ID. Again, this is basically a database table somewhere that is a role ID, client ID, server ID. And that's what this command represents, is creating that record that assigns this role for this client to that server. So I have one for read and one for write. And finally, I'm going to assign the roles for my user. So this will assign read and assign write for my not user. What I decided to do for our dev team was instead of assigning each individual user all these different permissions, I can also just assign all those users to a group, an Azure AD group, and then assign the group those permissions. So instead of me having to revoke individual users, I just say, if you're doing local development, get added to this group, and you're good to go. So over here, I need to actually assign those roles. So right here in our main set of infrastructure as code bits that are creating the server, our clients, and our external clients, I will go ahead and then assign those roles. So I say server.assign roles. It's going to assign those roles based on my Azure AD resources, and this is then just my user and the local dev group that I created earlier. Okay, so now with all this, I need to enable security through Swagger in my server. So I have to teach Swagger how to authenticate with Azure AD. So that's the next bit we're going to add here. So down here we have our app.useSwagger, and over here we have add Swagger. So in our Swagger configuration, we'll need to say, go ahead and authenticate via Azure AD with a specific flow. So I have to tell it, you're going to use the authorization code flow, which is the normal flow for a browser. And these are all the URLs you need to go to for the authorization URL, for the token URL, and the scope is going to be that local dev scope that we asked for earlier. Finally, down in the UI, we have to do a similar kind of operation. Then we say the client ID that I'm going to be passing in through the UI is this, and other junk, use PKC, PCK, whatever. All right, so now when we run this, we'll get this little padlock in our Swagger UI. When I make that call, authorize. Authorize against this scope. What is this client ID? Well, that is the client ID of Visual Studio, the well-known client ID, the F1. So if you Google that, you'll get lots of results back. I click authorize. Whoa, just went really quick. So I was already logged in to Microsoft Online, Azure AD. And so it said, right, you're already authenticated. Let's go ahead and grab a token. And so now at this point, it has a token it can use for any of these calls. So now when I test these APIs out, execute. And I grab, we got 200. So we got a good response, and we got actual responses back. And if I grab this bearer token right here, and I go to jot.ms, let's look and see what this token looks like. And so down here, I've got me, James Bogard. I've got my scope of local development. And hey, look, there are those roles that I assigned to my group. And the group, I'm a part of that group. That group has been assigned those permissions. And so now those roles get populated in the JOT. When I call the server, it takes those roles, puts them in the roles in my principal, and then in the authorize attribute, it just looks at those roles to say, do you have to-do.write and to-do.read? So now I can develop locally. Huzzah. All right, we're not done yet, though. That's just the server. We still have to worry about the external client and the Azure client. So let's do the external client first. Okay, so the external client, so what does the external client need? This is something that's not deployed into Azure, but still has to identify as an Azure AD resource so that I can get permissions assigned to it and it can acquire a token. So we first create our application. This is kind of funny because it's not something that actually gets deployed in Azure, but in order for us to assign permissions to something, I need to have some kind of securable resource. So I'm able to just create an application that never actually gets deployed, but is something that just exists inside of Azure AD. And again, all identity providers have some sort of concept of this thing. Azure has applications as well, and role-based access control. So it's a very similar concept across these different identity providers. The next thing I need is a secret. Now, there's a few different ways for us to acquire a token via Azure AD as a daemon application. You have the client ID, client secret option. So that works great if you can secure that secret. You can also use a certificate. That's my preferred option, is to use a certificate, because those certificates I can then store securely inside of Key Vault and have permissions associated with those. or you can use a federated token. The federated token is I am acquiring another token on behalf of another token I already have. We don't have that, so we just wind up going with the client ID, client secret route because it also is easier to build locally here. Okay, so I've got my application secret. I've got a service principal. And so that service principal for the external client is going to be the thing in which we assign these different roles to. My external client then needs to acquire tokens on behalf of this Azure AD resource. So we're going to need some configuration there first. Over here, we're going to pull over, right here. A couple things. One is the client ID of this external client. I need the server application ID, so I'm this client calling that server. And of course, we're just always going to need this tenant ID, so we have the tenant ID here as well. Now, in order for my application to acquire tokens, I'm going to need to pull in some additional libraries, or library, I should say. In this case, I'm going to be using the Microsoft.identity.client library. So we had identity.web. That was for the API. As a client, I can use Microsoft.identity.client. So I'm acquiring a token as a client to call something else. Now, if you've ever used Azure AD to secure like your database or other things inside of Azure, it's using these libraries underneath the covers as well. So we're using these libraries now directly to acquire tokens as opposed to being kind of transparent underneath the covers from calling these other Azure resources. All right, so we've got our client ID there. Next thing we need to do is modify our configuration. And there's going to be a ton of stuff here. So a few things here. One is we need to configure the Microsoft Identity Client to be able to call Azure AD to acquire our tokens. So that's what we see here. We're using this confidential client application builder. And what it gives us is this object called an iClient confidential client application. That is the thing that we'll be using to acquire a token. So it's an API that wraps up all the OAuth 2 business behind the scenes to eventually just get a token out from the other side. All right. The next thing we'll have is for each individual client we're going to be calling, I need to know like what is the application or server ID of whatever that is. And I'm going to be using the typed HTTP client way of calling these APIs. So each of my APIs has this interface. Feels like we're back to WCF again. But it has this interface to define all the different API endpoints to make it easy to call our APIs. And then our client is then just like call, get from JSON async / to do items, get put, post, and delete. So my application will call this object to make the HTTP class behind the scenes. And then the last thing we need is middleware in that API client so that every time I make a call to the API, it's going to acquire a token for me transparently behind the scenes. So I don't want all of my application code to be like, oh, I need to get this token, I need to get this token. So in this case, we'll be using handlers for HTTP clients to transparently get that token for us underneath the covers. So this confidential client application auth handler takes our confidential client application, so the thing we registered earlier, and then down here, it's going to say, I'm going to acquire a token for a client. And the scopes it's going to acquire for are just the default scopes. That just means I don't want any specific one. Just give me all the ones that I've assigned to me. And so it gets all those, gets an access token, and then applies that access token as a bearer token as an authorization header. So my client code over here and these workers is just getting the to-do items client, which is the type HTTP client, and just makes a call to say get. But in this code here, you don't see any authorization header or business. That was all done for us via that middleware. All right. So the next piece I need to do is I've got all the client code here. I need to then assign the roles for this new external client to my server application. So back in our infrastructure code, Let's go over to our server. We'll create some methods here. We have one method already to the Azure AD resources. We'll also do one for the external clients. Now, this external client, what I'll be testing here is this client does not have access to all the roles and only has permissions to do reads. And so I'm putting that kind of responsibility of who should have access to what roles. I'm really saying that's the server's job to determine all that. So that's why it's in this server class in my infrastructure code. Then we'll need to call this assign roles over here. So we've already assigned the group. All right. So let's go ahead and run the server and run our clients and see what happens. There's my server. I can authorize against that. Let's go ahead and run the external clients. And this, again, is just a daemon application that has background workers making API calls. Or it's already making API calls. It's making two API calls, though. One is just to the get, and one is to the put. It does not have authorization for the put, so that's why you see this 403 forbidden. I don't have that role assigned to my principal to be able to make that call, so the server is going to say you don't have authorization for that resource because you don't have that token. Let me go ahead and grab that token here and go to jot.ms again. And sure enough, we've only been assigned the read role, not the write role. The other thing that you could see inside here, like this is the audience, which is still Visual Studio. This is the tenant ID over here. And then over here, I think one of these IDs is the clients, and then one of these IDs is going to be the server itself. So it's doing all that for us transparently underneath the covers. When I call the API, it's checking all those values, and then finally the authorization for that attribute is then checking that role. All right. So that's our external clients using client credentials with the client secrets. The next thing we need to do is the Azure client, so something deployed inside of Azure. Now, we could go this exact same route, which is to say, let's go ahead and create our own client ID and client secret and put it inside of there. But there are some Azure AD resources that make our lives much easier to be able to have these kind of principles for things inside of Azure. So that thing is known as a managed identity. A managed identity is a Azure-defined principle that we can assign to specific applications, to virtual machines, all sorts of things. And then when my application runs, it's running under that identity of the managed identity versus something I just made up over here, like this external application, whatever. So our Azure clients, there we go. Let's go ahead and create this thing. So first what we'll need is, there it is. We need to create our web application that's going to be running inside of Azure. So that's this web app here. So it's still saying I'm going to be running .NET Azure clients. I also included some configuration to say, well, when I'm running inside of Azure, I need to know where the server is. And so I just have some app settings defined as there. The next thing we need is an identity for this web application. So this is going to be a managed identity, a user-assigned identity. Now, everything does run as a managed identity behind the scenes for you in like app services and things like that. But I want to be able to manage that identity myself, and so I'll be creating my own user-assigned identity, which then I will then assign to this web application. So here, I'll modify my web application definition to say this is your identity. This is really ugly code, but that's just because this ARM template garbage is sometimes really ugly. So anyway, I am telling the web application that you are going to run as this managed service identity. And then finally, I'll go ahead and output all these things down here. So here's my user-assigned client ID, the principal ID, and the host name that I can then spit out when I run my Pulumi up code. Next, I need to assign the roles for this client to that server. But I'm not going to be assigning the application. I'm going to be assigning the managed identity. So over my server, one more method to assign roles. I take in the client, and it's going to be assigning the read and the write permission for the user-assigned identity principal ID. So the managed identity is now going to be assigned those permissions. Finally, over here, when I'm assigning my roles, I'll go ahead and call that assign roles method. So here I have assigning the roles to my local dev group, the external client, and the Azure client. Now, this API, this Azure client, is kind of a cheat. So what this API is a mirror image of the Azure, of the server API. So it's got the same exact controllers, the same exact methods, except instead of like doing the real calls, it's calling into our client. So it's making API calls. So it's an API calling our API. This is meant to represent our BFF. It's an API that calls other APIs. But it's going to be using the managed identity to identify itself and authenticate against Azure AD. So I need to tell this API now how to make those calls and how to authenticate. So for this, we're going to be using another library that's azure.identity. So azure.identity is a library that you use whenever you want to use managed identities to make other API calls. So if you're deploying an app inside of Azure that calls into Azure SQL, it's going to be using this library underneath the covers to use the managed identity to authenticate to get a token to call out to SQL. The next thing we need to do is configure this. So let's go into our startup. Oh, configuration first. So go ahead and, again, I need to pull in the client, the client ID and the server ID. The client ID is the ID of my managed identity. So when I ran my Pulumi code, out popped the client managed identity client ID. And so I grab that value, and that's what I'm going to be putting inside of here. Next, I need to configure my application to be able to call those different APIs. And it's going to be, yes, right here. So for the Azure.identity library, we have a little bit different way of acquiring our tokens, and it's using this concept of a token credential. This token credential is basically wraps up many different ways of being able to acquire a token. One way is using Visual Studio. Another way is using the managed identity. It could also use environment variables. So this token credential, using the default Azure credential, wraps all those different combinations together so they don't have to configure, well, Visual Studio is this way, managed identity is this way, and maybe I'm using environment variables this way if I'm inside Kubernetes or something, or in a container. That's all part of that. Finally, we will add more configuration that is the API client configuration. So this is very similar to what we saw earlier of I'm adding middleware to be able to automatically acquire a token. I'm adding these type HTTP clients with a specific configuration with its different base addresses, and then adding the middleware for each of those clients so that when it makes those calls out to the Azure server, it's transparently acquiring the token. Now this middleware is slightly different than the previous one because it's using the token credential now, this thing, to acquire a token. It says the scope I'm looking for is, again, my application ID, the server application ID and the default roles for that, or the default scopes. It's going to call get token async, and then out the other side is going to be our JOT. So let's go ahead and run this. I'll run the server, and we'll run our client. Our Azure client. Now, I'm running locally, so I don't have a managed identity. So what that default Azure credential gives us is, if you're not in Azure and you don't have a managed identity, we'll just go ahead and fall back to your Visual Studio user. So when I make these calls, try it out. Execute. This is now using the Visual Studio context to say, oh, right, let's go ahead and use whoever you're logged in as inside of Visual Studio. So like up here, this user up here, I'm signed in. It's going to acquire a token, a POP, on behalf of that user. Oh. Well, I missed something. That's OK. We'll go ahead and run now. Oh, internet problem, of course. Always, always running on the cloud. So why don't we go ahead and look at the actual running Azure instance of this. So over here, oh, internet. If my internet was actually working right now, then my client running as that managed identity would be acquiring tokens on behalf of that managed identity to make the calls out then to my actual Azure server. Because I'm using managed identities there, I'm going to be using that same managed identity to secure all my other Azure resources. So accessing Key Vault or Azure SQL, anything else, it's using that same exact identity. All right. So just to wrap things up, we had our Azure Azure server. Oh, no, that's fine. I don't have one of those connections anyway. We had our Azure server running completely inside of Azure that was using Azure AD to identify itself as a resource using application registration. We had an external client using client credentials flow with a client ID and client secrets. We authorized that client using the application permissions. And finally, the 100% internal to Azure client here could use a managed identity to identify itself and make our lives much easier to be able to secure against our server as well as any other Azure resources. So that was building secure microservices in Azure. Again, I skipped all the networking stuff. There's a whole bunch of that too. I don't understand any of it. But this was the application aspect of it, of using OAuth 2 and Azure AD to secure different calls inside of Azure. If you want to see this example running, I have a GitHub, this link down here, github.com/Azure AD example. That is that full running application. You can use that Pulumi the Pulumi script to run that against your own Azure subscription and create those own resources for yourself. Otherwise, you can find this slide and the code on my github.com/jbogard/presentations. Thank you all very much. I hope you all have a great rest of the conference.